Okay, hello algebra students. Welcome to another riveting Mr. Ryder YouTube video. There were a bunch of suggestions for questions, but very few questions repeated more than once. So the two questions I'm going to spend the most time on are 17 and 31 because those both received multiple requests. Everything else, I'm just going to do like a really brief run over. I'm probably not going to fully answer the question super well, but if you want me to elaborate, pop in for our 3-minute mini home base tomorrow, and I'm happy to help as quickly as I can. So again, like these ones that were only requested once, I'm just going to speed run like literally 10 seconds so that this video doesn't get out of control long, especially since it is already 8 o'clock at night. So this one, you can either break apart the fraction first, and then like you can use decimals if you want to by dividing. I personally would just multiply everything by 12 right now. And that would get us, that's my alarm to remind me to do this. Good job, me. That would get us here and then just solve from there. There is a video in the Unit 1 in the test review folder called No Solutions, Infinite Solutions. I'm going to leave that version of me to explain these. No solution, infinite solutions, x equals 0. There's kind of the super fast. I am a goat collector. I wish this was a fact. That'd be a really cool hobby. I think the most confusing part of this for most people was the building the equation. The easiest way to think about it, in my opinion, is to say the number of goats you have starts at 4650. So there's our y-intercept. And then if it decreased by 3 goats every day, we would have that. But we don't decrease by 3 goats every day. We decrease by 3 goats every 2 days. Whether they run away in a pair one day and solo the next day, I don't know. Maybe it's 1.5 goats. Maybe they get to the fence and they half climb over. I don't know. But that would be the build of the equation. The line comes something like this. It should not go back here because that would be negative days. But that's just kind of a be careful thing. Like this would be 5,000 days, so you plug it in for D. This would be no more goats, so 0 is G, and then it's just a matter of solving. You guys crushed this, I guess. Here's the first one that had a lot of commotion, multiple requests. So this is a really reasonable one to feel a little bit thrown by because this isn't as directly something we did this year as most of them are. Most of them, like, we graphed a lot of stuff that looked like that. Maybe not with, quite that ugly of fractions, but we've done a lot of stuff like that. This is a little bit newer. The most common wrong answer I saw was this. And it came from a good place, like a place of good thought process, because people were looking at 6 o'clock and 11 o'clock, and they're like, it does increase. It goes from there up, and furthermore, it gets from here to here. That's totally an increase. The problem is when this is talking about a graph increasing, it means that it's strictly increasing over that time because it says a continual increase. Now, is this graph increasing? Absolutely. Is it increasing overall? Absolutely. But is it increasing continually? No, because in that interval, we see a decrease here from about 8 to 10 on the x-axis. Because there is that decrease, there would not be a continual increase, so we could rule out number 1. That is probably the answer to most people's questions. The answer is 3. There's a decrease in customers from 1 p.m. to 4 p.m. So from this point right here where it's 1 p.m. until 4 p.m., there is a constant decrease the entire time. The decrease is occurring like at every single point throughout the graph in that interval. Everything else is untrue. So let's kind of rule out the other ones. Increasing customers from 12 to 3. Was it increasing strictly from 12 to 3? It starts here. It ends up here. So it increases for a second, but then it decreases the rest of the time. And lastly, a decrease in customers from 11 to 2. That is saying we decrease from 11 until 2. It increases for a bit, and then it begins to decrease, but it is not a constant or continual decrease over that interval. This goes into interval notation slightly, though, so I'll take this opportunity to address that. especially for the average rate of change people that are a little bit confused. If I wanted to talk about, let's use the answer. If I wanted to talk about this interval from 1 p.m. to 4 p.m., I'm assuming p.m., there's a few different ways to say it, and one of the ways that seem to confuse people the most is this. This is saying that the x value, or the time here, could be anything in between 1 and 4. Now, the reason I say this means it's between 1 and 4 is because think of the values of x that would make that true. Sure, x could be 2 and x could be 3, but also x could be like 1.01, or x could be 3.94. X could represent literally any number between 1 p.m., I'm assuming p.m., and 4 p.m. So if it says something like this, 1 is less than x is less than 4, that's saying that we're talking about the interval from 1 p.m. consistently here until 4 p.m. It wants everything in between there. So also, like if it asks for the average rate of change between 1 and 4, you'd have your first point at 1 p.m. and your second point at 4 p.m., and you would use slope formula to find the rate of change between those 2 points. So that's what this interval is talking about. Another way it could be represented is it could say the x values span from 1 to 4. That's a little bit rarer because it looks like a coordinate point, but that's another way you could see it. The last way you could see it is it could say literally x equals 1 to x equals 4. Those are kind of the three main ways they could talk about this interval from 1 to 4. But either way, it is decreasing over that interval, and that's all that question was really looking for. Moving. This won't pop up tomorrow, I don't anticipate, nor the next day. However, it's probably not as bad as you'd think. It's asking about, let me kind of speed solve. It would be 4y equals 8 plus 6x. So y is 2 plus 1.5x, aka 3 over 2. So it's a graph that kind of looks like this. And it's asking, where is the line when x is negative 0.1? So when x is negative 0.1, the line's about there. So maybe like a little bit more than 1. And there's a few ways you could get that. You could type this into your calculator and graph it, and then in trace, you can type in a desired x value, and you could type in negative 0.1. It would just give it to you. However, the way that this was intended in week 2 or 3, whenever we did this, is that when you have the equation of this line, if I give you an x value, plug in the x value. When you plug in the x value, you can solve for the y value. So that would be 2 minus 0.15, aka 1.85. And if I give you an x value, you can solve for the y value. Likewise, if I give you a y value, you can solve for the x value. So that one's doable. Average rate of change. Average rate of change from Sunday's temperature to Thursday's temperature. Here's, again, I'm speed running these ones that are just one suggestion. Sunday temperature to Thursday temperature. When it's talking average rate of change, you want your start point, your end point, and you're finding the slope in between them. It is dropping from 25 degrees down to 19 degrees. And it's running from Sunday over to Thursday. So that, I'm assuming a day is 1. Maybe that was the confusion. 2, 3, 4. So dropping 25 down to 19, it's dropping 6 degrees, and it's going over 4 days. So it'd be negative 6 over 4, aka negative 3 over 2, or negative 1.5. Any of that would be good. If you wanted to see it a little bit more formally, you could call this, if you wanted to, you could say like this is 0.25, because 0 days into the cycle, or you could call it 125. Frankly, it won't matter, because if you call it 125, then instead of this being 419, it'll be 519. And either way, when you plug that in, you'll have 19 minus 25, 4 minus 0, or 5 minus 1, and you still get the same thing. What does the average rate of change mean, like in this question? It means every day the temperature is decreasing by 1.5 degrees, or every 2 days the temperature decreases by 3 degrees on average. The word every is important because rate of change means it continues. Average rate of change, again, from 1950, so that's here, until 1990, that's here. If I gave you a question like this on the test, I would expect you to guesstimate as best as you can. If you said, for example, that that was 13,000 as a Y value, that's great. That would work. If you said, for example, that is 700 as a Y value, that's great. Now, to be clear, if you said that's 600, no, you would not lose points. If you said 800, no, you would not lose points. If you said that's 1,500, yeah, you're going to lose points because 1,500 would be more than halfway up the box. That said, I do not believe there's any questions like this on there, but that's just kind of a rule of thumb. So to focus more on the average rate of change piece, which will be on the test, we're going from 1950 to 1990. So we're going from 50, 700 or something to 90, 13,000. Plug those into slope formula and you'll get this. And then reduce as needed. 1, 2, 3, 0 over 4. That's kind of cool. Maybe I'll leave it like that. Nope, psych. There would be your average rate of change. That is the increase in number of women earning PhDs per 2 years is what that would say. Okay, 27 got a star, but like there's a lot of questions there. So I think elimination as a whole is kind of the focus. Elimination, get X values or get Y values that are opposites so that you can add the rows together. That will allow you, 8x plus negative 8x is 0. That will allow you to focus on one variable at a time, solve for it, and then plug it back into either of the equations to solve for the other one. X would be 35, 40, so 5. So there's your final solution. If it doesn't already give you opposites like this one did where I was being very nice, then you'd have to multiply to get them. So here maybe you multiply by 3 because that will give you negative 3x, which is opposites with the 3x's you wanted. 28 also got a star. I think this one is a better one to star because these ones all had nice multiplying factors. Like this one multiplied by negative 3. I loved 3's here. Positive 3, positive 3. But down here, there's not super nice multipliers. So instead what I would do is that like flip trick that we talked about in class, where you flip the 5 and the 8 out in front. And I don't have to negate either of them because as they stand right now, these having opposite signs will already result in eliminatable resulting equations. So we'd have 40x, negative 20y, and negative 120. And then down here we would have negative 40x. Ooh, we like that. Negative 40y and 120. And then when we add these together, now we're eliminating the x value. You get y equals 0, plug y equals 0 back in, and x would be negative 3. So you could solve those as well. They're kind of the same way. Our next one that got multiple pieces of commotion. This is really just modeling equations. I would recommend reading slowly and building it in pieces. So 4 times the number. I am done reading for now because I'm going to say let x equal my number. And we are talking about 4 times the number. So here's 4 times the number. Now keep in mind, at this point, I have already started building. I haven't even finished reading the question yet. This is as far as I've gotten. 4 times the number is less than. I have not continued reading the question. I am building as I go. The sum of the number and 12. Here is the sum of the number and 12. After you've built it, the solving I think is pretty strong as a group. I'm assuming, because there's no notes, I'm assuming that the stars are as a result of kind of the funky wording on these. You could subtract x, you could divide, and you get x is less than 4. Open circle, because 4 is not included in the solution set, as 4 is not less than 4. And then we are less than that. Next one, 3 times the sum, pausing right there. If we need to multiply a sum by 3, that means we want the addition to happen before the multiplication. Well, that means we need 3 times the sum of something. So some needs to get multiplied by 3. Let's figure out what the sum is. So that sum is the sum of a number, and 5. A number and 5. And I would copy paste this down here. So this is 3 times the sum of a number and 5, and that is at least as much. So it's either as much or it's greater than. So it is at least as much as 17 more than the number. Here is 17 more than the number. From there, again, I trust your solving. You'd have 2x is greater than or equal to 2, so x is greater than or equal to 1. I just wanted to show the solid point because 1 is a solution there, because 1 is greater than or equal to 1, because the equals then is included. A quarter of the difference. Again, I want 1/4 of some difference. I don't know what the difference is yet because I did not continue reading, but I want 1/4 of the difference. So 1/4 of the difference between a number and 5. There is the difference between a number and 5, and this is a quarter of the difference between a number and 5. That's less than or equal to the sum. The sum of what? The sum of a number and 1. And then lastly, that one's pure solving. So hopefully that rundown is helpful. Literally just start to read it and then build whatever you need to build, then continue reading. Like do it in pieces. Reading the entire a quarter of the difference between a number and 5 is less than or equal to the sum of a number and 1 is totally overwhelming. So start to read, and once you have something buildable, build it. Just don't forget when you divide by a negative to flip the sign. Just to be clear, divide or multiply. Just to be clear, if this was a -2, for example, and we distributed it, we would keep the sign the same there because we're not multiplying both sides by a negative. We're just simplifying this side, which happens to have a negative being multiplied. You would only flip the sign. So just to continue from here. Again, I changed the problem, so it's not going to match the answer key. You would only flip the sign when you divide by the -2 here because you're dividing both sides by -2. You're allowing both sides to be influenced by that negative. So if before this side was greater, we've now negated it. So now this side is, like if it was more positive, it is now more negative. So therefore it is now less than the other side. And then I think there was one more problem mentioned down here. This is just a solve for y equals. I think the weirdest part of this, because you add the 9, so you have 3y is less than or equal to 21. So this. I think the weirdest part of this is that there's no x values. People might be thrown off, but y equals 7 is just this line. Notice how careful I am. I don't even know if that's 7, but just notice that I'm putting arrows. I'm making it all the way to the end of the graph, and I'm using arrows. If you guys stop your lines like here again, I am going to lose my mind. Stop losing points for that. Literally continue, draw an arrow. It goes on absolutely forever. So anyway, if y needs to be less than or equal to that, then we want all of the y values less than or equal to 7. That is all of them. None of these values count because those are like y equals 8, y equals 9, and y equals 10. We want down here. The other line is -4, -2/1. So it's like this, and we're dashing our line. And then, of course, we're labeling because we're very good about our attention to detail. And we're good about our labeling. And we're good about our shading because it's less than that. And we're good about our writing solution set, big S, whether it asks for it or not. Okay. Any other questions you got? If it's a last second thing, or if you have questions and you're more confused because of this video, pop in for the start of home base tomorrow. I know it's only 3 minutes, but if you come right at 8:05, you might be able to get a question out of me then. Happy to help. And otherwise, I will see you in school tomorrow. Good luck to everybody.